Welcome, ladies and gentlemen, to the public forum here on the group exhibit of hydrogen and fuel cells on Hanover Fair 2013. I'm very proud to announce to you that today is our European Union Day. So we will present a lot of interesting projects and thoughts coming from the European Union. And I'm very happy to have here from the Fuel Cells and Hydrogen Joint Undertaking, the project manager, hydrogen production and distribution, Dr. Nikolaos Lymperopoulos. Very nice to have you here. Dr. Lymperopoulos, please take a seat. That is your applause. So this is just an introduction to the first topic we are heading at today, energy storage and renewable energy sources. And if you're interested, I would like to invite you already now. In 20 minutes, we will all move to the technical forum, where we'll have some interesting presentations about that topic and also discussion for 1 more hour. So we really try to get deep into that topic, but here on the public forum, we are just trying to touch the topics, but also to discuss it a little bit. So whenever you have a question, feel free to raise your hand. I'll be with the microphone right with you, and we can discuss it already here. Dr. Lymperopoulos, maybe we have to explain a little bit about the Fuel Cells and Hydrogen Joint Undertaking.
Yes.
What is that exactly?
It's a public-private partnership between European industry and the European public. In this case, it's the European Union, represented by the European Commission. The two have joined forces and have established this legal entity whose aim is to support the development of fuel cells and hydrogen energy technologies and support them in their market entrance.
So I can imagine a sort of assembly of the representatives from the member states, from the European Commission, and also from industry
European industry as well.
European industry as well, and research institutes probably.
Correct.
Okay.
Yes, indeed. There is an industrial grouping, there is a researchers grouping, there is the commission there, and this joint undertaking has secured a budget for its purposes. It's almost...
Which is always very important to have a budget, yes?
Indeed, which is fenced. So there is no competition, let's say, from other technologies, which has been a very positive development and which applies for other joint undertakings as well. So there is a budget of €1 billion almost for a period of 5 years, 2008 to the end of this year, 2013. We hope that there will be a second stage coming up under Horizon 2020 with an even increased amount.
Even increased?
Yes.
Okay. Yeah. So that's what I can imagine. So you have 1 billion for a long period of time, of course, and for a lot of member states and a lot of research institute and a lot of industry. And you're all together, sitting together and thinking, what are the best projects we could imagine that could be funded, that could be brought on the way?
Indeed. We have a multi-annual implementation plan which is designed jointly by industry researchers. We also contribute in this. And then we break this down to annual implementation plans, which we use as a basis to publish calls for proposals for European consortia to apply for the available funding. The funding of 1 billion actually comes 50% from the European Commission, and the other 50% comes from industry in the form of matching funds.
As you said, private-public partnership, yes.
Indeed.
We have the first question here from our audience. I will come with the microphone directly to you, and if you would like to introduce yourself, would be very nice.
Thank you very much. My name is Dapo Ogumuyiwa. I'm an automotive consultant. Now, you said you have your budget of 1 billion for the next 5 years or so, but you're also aware in 2020 we're having the European Union's emissions requirements of 95 grams per kilometer. From the European Union and European Commission, where that money, we feel that money will best be spent is not on the research, but providing the infrastructure for the hydrogen refilling stations across Europe. Because by that period of time, the technology will be there where we'll have hydrogen applications but what will be missing will be the infrastructure on a European basis.
Very
Well,
good question, but
yes,
to be
and
honest, it's not-
indeed,
yeah.
the 1 billion is used for both research and improving components and systems, but also for establishing the infrastructure, at least for a pilot scale. Okay, so there are research projects and there are demonstration pilot projects that deal with this type of infrastructure.
We will talk in 1 hour about infrastructure. So we concentrate in this session about energy storage and renewable energy sources. With Mr. Froy, in 1 hour time, we'll talk about infrastructure, definitely. So we get deeper into that. But I may have got your point that you say, well, we have to do something to reach this 95 CO2 per gram CO2 per kilometer. But maybe not only with hydrogen and fuel cells.
Correct, but for sure hydrogen and fuel cells will help, especially if you integrate hydrogen with renewables, which is the point of proving hydrogen's sustainability and zero CO2 emissions.
Dr. Lymperopoulos, but this brings me to the point to ask, well, where is the definite link between renewables and hydrogen? Why do they have something to do with each other?
It's a win-win for both. Hydrogen must associate itself with renewables if it wants to prove its sustainability. This is for sure. And renewables, on the other hand, have to benefit from hydrogen because hydrogen can be used to store any excess energy from renewables. So we are creating, let's say, a new market for renewable energy sources. And I hope that the renewable industry will appreciate this. The the electricity system operator will also appreciate this. New roads to, let's say, wind energy, for wind to power the transport sector, for example. Of course, you can have pure electric vehicles, but electric with hydrogen and fuel cells will have the longer ranges and the other advantages we all know of.
Everybody's very much excited at the moment of the opportunity to use the exceed wind power we have in Germany, especially at certain times, or even exceed solar power, to use it to produce hydrogen and to reuse it. That is exactly this you're researching on and you're doing demo projects on.
This is correct. There seem to be three routes that one can follow. One is to produce this hydrogen and then pump it into the existing natural gas network, provided this is available. One can store bulk hydrogen in underground caverns, and there will be such a discussion in the technical forum that follows this. And one could use this hydrogen to refuel vehicles, which is another alternative.
It's always important to talk about business cases and markets, especially on a business fair like this is one, industrial fair and business fair. Do you see any early markets we can use this connection between renewables and hydrogen?
Most definitely. I think in Europe we have many islands or remote locations where energy is expensive, where renewable energy sources have limited penetration because of technical limits, and this is where hydrogen can help increase this local production of clean electricity. Plus, recently we've realized that in countries like Germany that have an overcapacity of wind energy in the northern part of the electrical system, there is a lot of excess, and this excess energy one could use to produce hydrogen and use it to store it or...
But is that already a business case? You know, the exit energy there doesn't cost very much, but the electrolyzers cost quite a lot.
Yes, it is true. Okay, the classic early examples are hydrogen in forklifts and UPS applications. That's fine. Hydrogen from renewables, maybe in some islands today would make sense, or some remote houses or huts, etc. But still, one would need some kind of support, and this is where the JU comes in to provide this type of support for early demonstrations.
Support also to come down with the costs for the electrolyzers, for instance, because the electrolyzers are the costly thing about it. You need to have them to get the energy from the wind into the electrolyzers to produce hydrogen. I know there is one project called Resolyzer, pressurized alkaline electrolyzer with high efficiency. That's one of your projects.
That's indeed the case. Our projects help improve the efficiency, longevity, and reduce the cost of components. In this project in particular, there is effort to improve alkaline electrolyzers in terms of dynamic performance. Usually alkaline are used for steady hydrogen production. So this project is looking at improving alkaline electrolyzers to work on the dynamic with new cells, membranes, control strategies, what have you. And then again, we have the Don Quixote project that will also be presented in the forum that looks at PEM electrolyzers. And
so there's a discussion here on the group exhibit. What is better for the megawatt applications of electrolyzers? And some say it's alkaline, it's cheaper, we can do it even with different load cycles. And others say, well, PEM electrolyzers is better because, you know, we are much more flexible and the overload we can come along with much better. What is your personal thinking?
Well, I would leave this to the electrolyzer manufacturers, but
you have to decide. When you say, well, what project shall we fund? You have to decide which is probably on the better path.
Yes, that's the case. But each one has its advantages and disadvantages. One has to decide on a case-by-case basis, I guess, for such projects, which one is the best one. You don't want to eliminate any technologies at an early stage. You have to support industry, develop its tools, and the market will eventually take the one that it prefers.
We were talking about resolyzers, going on alkaline electrolyzers. Don Quixote, you mentioned already, going to PEM electrolyzers. I like the name Don Quixote. It's like, there are still people fighting against windmills, are they?
Yes,
in Europe?
yes.
That's why you
This
you
is the
choose
case for
Don
hydrogen,
Quixote.
it seems. Yes, I think it was a very successful acronym from the consortium.
Okay, it's an acronym, I see. So with Don Quixote, you not only look into putting renewables into into hydrogen, but also to use it for mobile applications. That means you produce the hydrogen on site and put it to a filling station then.
Yes, that is correct. I appreciate there is an existing facility, and this project will add components to this facility, and eventually the hydrogen will be used to refuel vehicles.
But the problem is where you have wind, like in North Germany or Northeast Germany especially, there are no fuel cell vehicles at all, you know, so you have to transport it to the next big city. Like it happens now in Prenzlau, where the first power to gas is there in situ, and they bring the hydrogen back to Berlin.
Transportation is an issue, and one has to look at the optimal ways to transport hydrogen, either with trucks or to liquefy it and then drive those liquefied hydrogen trucks, or actually to inject it into the natural gas network and use this high-thane in your devices, or even have at the end location special membranes that will separate hydrogen to natural gas, and then you can use the hydrogen in...
That's very interesting. Sounds very interesting to me. So this idea hasn't been mentioned here on stage yet, but it's very, very interesting. So once again, you put the hydrogen you produce into the natural gas
into the
grid.
natural gas, so you transport the hydrogen through the conventional natural gas grid.
Right.
And at the point of use,
Yeah.
developments are currently taking place to develop membranes that will separate.
Because hydrogen is much smaller than CNG.
Indeed, will separate the natural gas to hydrogen, and you can use them in different applications. Maybe refuel your vehicle with pure hydrogen, use the natural gas.
Seems very clever to me, but this technology is not ready
It's
for
not
market.
there yet.
Uh-huh.
No.
But this is probably one project you will fund, won't you? You can't decide, but you will propose,
if it goes,
maybe.
yes, into the MIPE, into the multi-annual implementation plan, etc. Yeah.
Okay, so then you could get rid of transportation of the hydrogen, like if you produce it on site and transport it 150 kilometers away to Berlin, the CO2 balance is not as good anymore, and if you liquefy it to transport even more, the efficiency is less.
Yes, that is correct. Although we are also supporting a project to improve the efficiency, to double the efficiency of the liquefaction process. There is the Ideal High project that we are supporting that is looking exactly at this. Currently, you need to spend 40% of the energy of hydrogen to liquefy it. Through this project, it is foreseen will be 20% only.
Okay, then you have it under higher pressure. Then, or how do you?
It's liquefied.
The liquefied.
Liquefaction, yes.
Okay, not by cooling it, but
It's through cooling and higher pressure
I
that
see.
you
Okay,
liquefy hydrogen.
both sides. Okay.
Yes.
Because you have to cool hydrogen up down to 250 degrees minus, so that is
exactly.
very costly, isn't it?
Indeed,
Uh-huh.
indeed. Energetically
I would
costly.
like to open the round. When you ever have a question to Dr. Lymperopoulos, just raise your hand. I'll be right with you with a microphone. There's one other project we will hear a little bit more on the technical forum,
Indeed.
which is High Under. What is that? It's not Down Under. This is Australia.
It's not Down
High
Under.
Under is something else.
That is correct. Apparently, there are suitable geological formations in Europe, like salt caverns, that are suitable for bulk storage of hydrogen, CO2 as well, but hydrogen as well. So this project is investigating both the right geological locations in Europe, and apparently there are some in Germany and in Spain, in combination with locations where there is excess of renewable energy sources. And this combination could lead to sustainable or financially viable applications where you can store bulk hydrogen in these caverns. So they're looking both technical and financial options on how you could do this.
I'm not so sure, but when there was a large discussion in Germany about CO2 sequestration and
Yes.
putting the CO2 underground into caverns also,
Right.
and the public were very much against it. Aren't you afraid that it's even worse with hydrogen? Because CO2 is heavy, it stays down there, but hydrogen will come up as soon as it can.
Yes, well, that's part of the positive aspects of hydrogen, the fact that it disperses so quickly and doesn't stay.
But nobody wants it up in their houses
Well,
and
indeed,
surroundings.
but these caverns will not be underneath houses. So I would guess they would be in remote locations. But this is part of the study to identify suitable locations technically, maybe also socially.
I think the social aspect is very important also. We always talk about technology, especially on the group exhibit hydrogen fuel cells, and very few experts understand what we are saying here. But we have to transport it into our community. Everybody has to support it, that it becomes reality. Are you doing something for this social awareness, I would say, about the technology?
Yes, there is a whole thematic area, application area, which we call cross-cutting issues, that covers the other areas of production, of transport, of stationary and early markets. And part of these cross-cutting issues is indeed the public, education, information campaigns. So it's a very, very important part of the hydrogen inclusive economy.
Very good. We now start at the technical forum with a panel discussion and different presentations about energy storage and renewable energy sources with Professor Andreas Friedrich from Deutschen Zentrum für Luft- und Raumfahrt e.V. He's already here. He will follow us to the technical forum immediately. He's responsible for the Resolyzer project. He's a partner there. We will see Dr. Olaf Kruk there from KBB Underground Technologies for the high Lande project, and Raimund Schmidt from Hydrogenics Corporation he's the Don Quixote project coordinator. So please follow us to the technical forum, all of you who are interested in this topic, and take part in the presentations and also discussions. Thank you very much, Dr. Lymperopoulos, for this talk.
Thank you.
Thank you.